Hello and welcome back to the power supply design video series. In this video, I am going to go through basically adding all the switches that I've spoke about in the last video, which will help to control the power flow from the USB-C connector and the two batteries that I spoke about. So we've got the 4 AA cells and the rechargeable battery. From the last video, obviously I said that I'm not going to be connecting the buck boost converter to the USB-C port. So I'm going to disconnect this and disconnect this and bring that down somewhere here. This point will connect directly to the three regulators, 1, 2, and 3, when the USB-C connector is plugged in. We have the 5 volts here. I need 2 more of these for the battery connections. So I'm going to label those two as plus AA and minus AA. This will have a range of 3.6 to 6.4 volts. So the way I'm going to connect this up is using this layout you can see on the screen now. So obviously I've got 3 inputs. So I've got USB 5 volts, I've got 4 AA cells, and I've got a rechargeable cell. The USB should connect to the rechargeable cell all the time. If the USB-C is plugged in, it should charge the battery basically. Then this goes to a single pole double throw switch where the AA cell is connected to one of the throws and the rechargeable battery is connected to the other. So obviously pressing this switch will allow the user to basically switch between the connection to this or this cell here. And that provides power to the 5 volt buck boost converter. The output of the buck boost converter then goes on to another single pole double throw switch. So one of the throws is the USB-C connection, which is the 5 volts coming in, and the other throw is the 5 volts from the buck boost converter. So the user can press this switch basically to select what powers this. So if this is selected, then one of these will be powering all 4 of the regulators here. If this is selected, then obviously it'll be coming from USB-C connection. From this layout, you can see we are ensuring that there is no way that the USB-C connection is going to be backfed into any of these cells here. We're not wasting power basically connecting the USB 5 volts to the buck boost converter and then connecting it to this point onwards. So with these 2 switches, we should be able to control the power flow of this circuit. So now let's implement that on KiCAD. The buck boost converter is basically connected to this switch here. And the switch toggles between the battery and the AA cells, which we have on top here. The next thing, we need to have the USB 5 volts going to one of the throws on this switch and the 5 volts from here going to the other throw on that switch. And then finally, this is basically our 5 volts controlled. So I'm going to add a new power pin. I'm just going to call it 5C. It's just a different label, and for me that's 5 volts controlled. Now connecting this up, and what I would need to do is make sure that this is connected to my 3 regulators. So it will go here, it will go to this node here and this node here. So we got our 3 converters connected to this, and obviously this switch will toggle between the USB-C supply and the 5 volts from this buck boost converter. You can see the V bus is always connected to this TP4056, which is the charging circuit for the rechargeable cell. Next, I want to add the banana sockets for the 3 power supplies that I have on the screen now. So I've selected 4 different colors for the banana jack. So I've got red for the plus 24, I've got green for the minus 24, and then 2 random colors for the 5 volt and the 3v3. And I have black for the ground. So let's do the PCB design now and bring in the changes from the schematic. So you can see I've got the 4 banana jacks and I've got the 2 switches. So they're quite the biggest parts that I have on the board. So now I'm going to do the PCB design on this. Hopefully you enjoy the video, and I'll catch you on the other side. I had some push switches I used on the design, but I'm going to go onto rocker switches. Obviously, it's difficult to find SMD rocker switches, but I'm just going to have some mounting holes on the PCB to allow for that. So I've made those changes. I'm going to go into PCB design and update the design with the changes I've made to the schematic. So you can see now I've got switch 1, switch 2 and switch 3 as mounting holes, so I can mount the switches off on a separate panel if I need to, and then I've got the mounting holes for the PCB itself. So now I'm just going to finish off this design with all the connections that need to be made, and I'll see you on the other side. So finally, the board is brought together. We have the switches now that control the power delivery to the various parts of the circuit. The last thing I need to do is order this board and we will test it. Obviously you can see the board is a little bit messy, but it is a learning experience, and this is the first time obviously I'm doing anything on screen. And as I built the board up in pieces and, you know, like one circuit at a time, it could have been a lot more compact than it is, basically, is what I'm trying to say. At the moment, the board size is basically 6 centimeters by 6.5 centimeters. So it's not the biggest board in the world. It's fine, and it can give us 3.3 volts, 5 volts, 24 volts, positive and negative. So there is a lot of functionality from this board, and we will be able to do loads of different things with this. So obviously one of the questions in the art of electronics is around switches. So I've just ordered the switches, and hopefully this board can power that up. So thank you for watching today, and in the next video we will have an unboxing for this circuit. Bye for now. So as a final step, let me show you how to generate the manufacturing files for this PCB. So what you do is go on to plot, select the layers that you need to plot. So obviously in this case I'm using a 4-layer board. I need the mask, cell screen, paste and the edge cuts. So I will press the plot button, which will make the manufacturing files and then generate the drill files. To check what we have just generated, you can go into the Gerber viewer, open Gerber plot files. And you can see we've got the various layers that we had on the board, and it all looks okay. Obviously this board didn't really need to be a 4-layer board, but I just did it for a bit of fun.